Hi guys, this is third question on collision for response homework paper. So we have two objects and they are attached with a spring in between them, and then there's another tiny object that is hitting the 2 kilogram object from the left. We don't know its speed, and the spin constant in between the two objects is 200 newtons per meter, and this guy is stop at the end, so there's this removable stop so it doesn't move anywhere. And once it hits that tiny object, hits that 2 kilogram object, it moves, it compresses the springs by 0.4 meters. And in the first part, they are asking for energy stored at that spring. So actually, if you think about the AP questions, they are going to start with the easy questions. Or they're going to start with the information that you might use later. So then, in that sense, first parts are going to be easier than the others. So do not think complex for the first parts. So then, since they're asking for the energy stored on the spring, you should remember that energy on a spring is given by 1/2 kx squared. So we know the k of the spring, we know how much it is compressed. So once you plug in the numbers, 1/2 200 times 0.4 squared, then once you do the calculation, you will see that this is 16 joules of work. Alright, so that's part A. It's short. In part B, so what they asked for, speed of that tiny clay right before it hits that 2 kilogram object. So you might be thinking that you are going to use a conservation of momentum equation over here, but that's not how you're going to approach that. And how are you going to know that you are not going to use conservation of momentum? Unfortunately, there's no answer for that. As you solve more and more problems, you will kind of sort of figure out. Or you will try conservation of momentum, but you will see that you don't know anything about the speed afterwards. You don't know anything about initial velocity, so that's not going to get you anywhere. So it's easier to start with the conservation of energy, because you know that at the end, initially there were no potential, and then what happened, this guy has moved and then compressed it by that much of distance, and it stored that much of an energy. So that means you basically store 16 joules of energy, and to be able to do this, you need to have 16 joules of kinetic energy. So, and if you think about it, this US must be equal to kinetic energy of that clay and the block system, because this energy didn't come from nowhere. This energy came from the movement, the kinetic energy of those two objects, and it stopped at the end. So that means all of that kinetic energy is converted to that potential energy. Then if you use it, 1/2 mv squared, then US is 16 joules. We calculated in the previous part, and it's equal to 1/2 times mass. So we are talking about this clay plus block mass, so it's going to be 2.1, and the velocity of those two guys is the unknown. Then once you solve this for equation, once you solve this equation for v, then you will find that this v is going to be equal to 3.9 meters per second. All right. And in part C, now they are actually asking for, or now we are going to use the conservation of momentum. So what they asked for is calculate the initial speed of v. So we didn't know what this v is, so they were asking for the velocity of this block system. Now they are actually asking for that velocity. So now we know that at the end they're going to have this speed. Then M1 V1 initial plus M2 V2 initial must be equal, so they're going to stick together, M1 plus M2 times V final. So now, initially this guy is going with V that we do not know. Initially it has a mass of 0.1, plus initially this 2 kilogram object is at rest, so that's not going to have any momentum. And at the end, 0.1 plus 2 kg times V final. So now we found that V final in the previous part. It is 3.9. So basically 0.1 V equals 2.1 times 3.9. Alright, so you gotta be careful with the dots because it seems like complex. So just be careful. So once you do the calculation over here, what are you gonna find? You're gonna find your velocity as 82 meters per second. And that's part C. And in part D, they are asking for state whether the maximum compression of the spring will be greater, equal, or less than 0.4 meters if you didn't have this stopper. It would be less, because if I can write, sum of the energy would be used by 8 kilogram object. In part E, they are asking for the which equations you would use to find that you would find that velocity. So in this case, you're going to have those two objects, initial and final. So initially, what is happening, this basically M1 V1 initial plus M2 V2 equals M1 V1 in final, M2 V2 final. So initially you have, so right now this is going to act like one object because we are trying to figure out what's going to happen to the motion of those two. So 2.1 kilogram object is going to have the velocity of 3.9 meters per second, plus this guy is at rest initially, so 0, and that is going to be equal to the final momentum of, they are not going to be sticking together, so they are going to have a little bit of different velocity. So we are going to have 2.1 times V final that we don't know, then we can just put the V1 plus we are going to have 8 kilogram object and we do not know its velocity either, so it's going to be V2. So that's going to be the first equation that we're going to use. And second equation will be conservation of kinetic energy. Same principle, put 1/2 M1 V1 squared plus 1/2, and that's the initial, 1/2 M2 V2 initial squared, and that must be equal to 1/2 M1 V1 final squared plus 1/2 M1, not M1, M2 V2 final squared. So this is number 1 equation, and your number 2 equation will be basically substituting this equation with the numbers. So that is 1/2 2.1 times 3.9 squared plus this guy is at rest initially, so plus 0, so I'm not going to write it down, and that's equal to 1/2 M1, which is 2.1, times V1 final, which we can call V1, because we use v1 over here that we don't know, plus 1/2 times 8 v2 squared. So that is going to be basically the final, or the second equation that you use to find your velocities for both of the objects. Alright, so that is the solution for question 3 on your homework.